Okay, then next I'm gonna go through some of the practice questions. I'm gonna go through all the even number of the question, and the odd number of the question has the answer on the back of the book. This is the first video I'm going to talk through. This video I'm going to talk through from question number 2 all the way to question number 14 and all the even numbers. So question number 2, we're having integral 8 3 minus 2x to the power of 5 dx. So for this question, you really cannot integrate it directly unless you want to extend this such that multiply this 5 times and then get combine them, get a pieces of all this x to the power of 5, some number multiply x to the 4th, then you do them separately, which is pretty much in pain because there's a lot of calculation involved. Now, if we use the use substitution, will make it easier. Normally, this may first it doesn't look like a substitution because only have a number, this only have one x, but because this is degree of 1, when you take a derivative of that, you will end up with just a number. Therefore, this could be a u substitution. Make u equals to 3 minus 2x. Normally, when you have a structure, a complicated component to some exponent, that complicated component will be your u. Now, this is u. Du will be negative 2 dx. Then, let's see. So we want to change our question such that it will have this portion in there so that we can replace it. Therefore, I'm going to create a negative 2 and dx. And this way, I don't have to change anything. This is x to the 5 because this ultimately becomes u. Now, if this is negative 2, I want to come up with numbers such that equal to 8, so that it's exactly the same thing. Therefore, this has to be negative 4, because these two together is positive 8. This is stay the same. Everything stays the same. I just rearrange all the numbers and elements. And this is your du. This portion is your u. This is a number. It's pretty easy to handle. Now we have negative 4, u to the power of 5, and du. And that is something we're able to handle. We're having a negative 4, u to the power of 6, and a 1 over 6, and a plus c. And that will give us negative 2 over 3. Now we can plug back in u, which is 3 minus 2x to the power of 6 plus c. That will be our final answer. That's number 2. Number 4, we have integral 10x 2x squared plus 1 to the 3rd dx. And u will be 2x squared plus 1 because that's within your structure. And du becomes 4x dx. And your question becomes, I'm getting a little faster, I'm jumping lots of explanation because that one is pretty in detail. This is very similar. We want to have 4x and dx. So I'm going to take away 4x so that the rest becomes 10 over 4 and 4x and 2x squared plus 1 to the power of 3 and a dx. And this 4x and the dx becomes my du, and the answer becomes, or I'm going to rearrange, do the substitution, that would be 5 over 2, u to the 3rd, and du. And the answer is 5 over 2, u to the 4th, 1 over 4, plus c. Then you can substitute it back in and also multiply this out. This is 5 over 8, 2x squared plus 1 to the 4th plus c. That's question number 4. Question number 6, it's integral of x to the 3rd plus 2 and x to the 4th plus 8x plus 3, 1/3 dx. And your u is x to the 4th plus 8x plus 3, and the du is 4x to the 3rd plus 8. Now this two looks very similar, except, dx, except I can multiply a 1/4 from both sides, such that it becomes exactly the part I'm looking for, and so that the question becomes integral. These two together, this will be dx, I'm sorry. This two together is 1/4 of du, so it's u to the power 1/3 and 1/4 du. and it will be 1/4. U will be u raised to 1 will be 4/3, and 3/4 to balance plus c. And then you multiply this two number, you get a 3/16, and u is x to the 4th plus 8x plus 3 to the power of 4/3 plus c. Now you see the advantage of doing this. If you don't have that, you have to multiply this out, or maybe you cannot even multiply out because this is the power of 1/3. If that's the power of 2 or 3 or 4, you want to extend it. Let's take a much longer time, a lot of calculations. Then, okay, no, give me 1 second. Change it. See what I can see it. Okay. Okay. Then number 8. What we have is, you know what, I'm going to skip number 8. Number 8 is very similar to number 6. Now I'm going to work on number 10. Number 10, integral cube the root of x plus 1 dx. Then we want to set u equal to x plus 1. Then du, in this time, is just 1 times dx, which is exactly equal to dx. Therefore, your question becomes into square root of u, cube the root of u, and dx is exactly equal to du, you can just replace it. And then this becomes u to the power of 1/3 du. And raised to 1, that will be u to the power of 4/3 because you're raising to 1, 3/4 plus c. And changing this x plus 1 back to u will be 3/4 x plus 1 to the power of 4/3 plus c. Okay, now I'll talk about the rest of the question in another video. I have to erase this. It's to take a big time.